So today we will take a new DSA question, and the question is top view of a binary tree. So we have already looked for the left view of a binary tree, right view of a binary tree, and tree traversal techniques. There I have explained multiple ways to print the left view and right view. So today in this series we will cover the top view, and then after this we will cover the bottom view of the binary tree. So what is the top view? I have already explained in brief, but let's take it in detail. So what is the top view, right? So one binary tree will be given, and your task is to return its top view, right? When we look at the tree from the top, then whatever the view we can see, that is the top view basically, right? The top view of a binary tree is the set of nodes visible when the tree is viewed from the top, correct? And return the nodes from the leftmost node to the rightmost node, and if two nodes are at the same position horizontally distance and are outside the shadow of the tree, consider the leftmost node only, correct? So it is saying basically, so this is the tree. Let's take an example. So here this is the tree, and for right view what we were doing, so this is the right side, right? This is the left side, this is the top, and this is the bottom of this tree, right? When we stand right side, right, and we uh, look at the tree, and this is the right view, whatever we can see, that is the right view, right? When we stand left side, right, and we look at the tree, so that is the left view. So from left side we can see this 2 and 3, 1 and 2, and from right side we can see 1 and 3, right? We cannot see 2, correct? So likewise there will be a top view and bottom view, right? So let's talk about top view. So here we are standing top, right, uh, at the tree, and if we look, right, then so we can see this 2 first node, right? We can see this one, we can also see this one because nothing is in front of this one, and also we can see this one also, right? So 1, 2 and 3, these 3 nodes we can see, correct? So the output should be from the left, right? So it is saying the return the node from the leftmost node to the rightmost, right? First we have to print the left, whatever we can see, right? So in this scenario we can see 2, 1 and 3, so the output should be from left, so 2, then 1, then 3. So this should be your output, correct? So I hope you are getting this. Let's take one more example here, this one. So here this is the given binary tree, and here we are standing at top of this tree, and if we look, right, so this is we can see this one, right? We can see this one, correct? We can see this one, nothing is in front of these nodes, but see 60, so 60 is behind the 10, correct? And this 90 is also behind the 10, because these are the overlapping basically, correct? And then we can see right side 30, we can see nothing in front of 30, and also we can see 100 here, right? So the here output should be 40, 20, 10, 30 and 100. 60 and 90 cannot be the output, because 60 and 90 nodes are hidden by the 10, or you can see if we look from the top, then 60 and 90 will be below the 10 exactly, so we cannot see 60 and 90 here, correct? uh, so yeah, so this is the top view. Now I hope you understood what is the top view. Now think about the solution algorithms. How can we implement right, effective algorithms, so where we can print the top view of a given binary tree, correct? So if you have any different solutions, whatever than mine one, then please comment below the video and let us also know about what you are thinking. So what I am thinking here is, there are multiple approaches of the tree traversal techniques, right? A pre-order, post-order, level order, right? Spiral order, There are multiples. So I will try to make use of all these tree traversal algorithms to print the top view. So what I will do for this one here, either I can make use of the that recursive tree traversal techniques, right? Recursive, it could be pre, right? It could be post order, or it could be anything, right? And then second, what I can do, I can make of that iterative approach, that is level order, right? So these are the techniques which we can use in this problem. I will explain with the recursive approach with the pre-order, right? And the upcoming video where I will cover the bottom view, there I will explain the level order, so that you basically get familiar with the all the approaches as well, right? So how can we do that with the pre-order here? So what we can do, what we do in pre-order, first we print the node, and then we go left, and then if left is not there, then we go right. So that is what we have, correct? So here what we will do, so for example, we will have our top view, right? Top view, and here we have root, correct? Then what we will do, we will basically pass the distance, right? So horizontal distance basically. So these are just draw imaginary lines here, right? And this is the zero distance, you can say, at root. This is the zero distance. If we go left, then this would be -1 distance, and if we go right, then this would be +1 distance, right? So these are the horizontal distance we can calculate. So one parameter we will take a distance, right? One we will take a level, right? And then we will take a map also here, correct? So why level? Because for example, in the below case, see here, not in this case, yeah, this one. So if we go left and then right and right, so see here for this one, let me explain you this use case first. So here the distance of this one is 0, distance of this one is -1, right? And then if we are going right, so distance of this one is again 0, right? And distance of this one is 1, and this is 2, and here the distance of this one is 1, correct? So in map, what we will do, we will go left, right? And if that particular distance, the entry is already there in the map, then we will check for the level. If it is the level, if the level is lower than whatever the entry is there, right, then only we will insert that new value into the map, else we will skip it. So in this case here, so first we will add the entry 0 level, sorry, 0 distance, and here the entry would be 1, and the level is here, right? So level is 0, this one, correct? So this is 0 level, 1, 2, 3, and 4. So the level is 0, right? Then we will go left, and we will check for this -1. Is it there? No, it is not there entry. So we will add one entry here, 2, comma, level is 1, right? Then we will say here 4. At 4 the distance is 0, correct? So distance is 0, so 0th entry is already there for 0 key, right? And now we will check for the level. So here level is 2, and the inserted values level is 0, so we will not insert, because this is the higher level, and because the lower level will be always top, so we will skip this value, correct? And likewise for this 1, we will add 1 here. Key 1 is not there in map, and the key is node value is 5, and level is 3, right? And here for 6, this is 2, right? Distance is 2, and the value is 6, and level is 4, right? Now we will come back from here, and when we go for this right value here, correct? And here right, this distance is 1, so distance is 1, but for 1 the entry is already there, so now we will check for the level. So the level is 3, right? And here the level is 1, so we should insert this value, because this will hide this 5, because this is on in the same level. You can see here. So if we draw horizontal line here, then this 3 is in front of 5 if we look from the top. So here, that is why what we will do, at the distance 1, we will update this value by this node, right? That is 3, right? 3 comma level is 1 here. This will got updated here, and that's all. So now, and after this, we have inserted all the values into the map, right, according to the level and distance from the root node, correct? And now we will take all the node values here, and as this is a map, so it would be sorted, right? So -1 will be printed first here. So 2, then 0, right, 1, and then 1 value, that is 3, and then 2 value, that is 6. So this is our output, 2136, correct? See here. So I hope you are getting it. This is the algorithm whatever I am thinking, right? So if I implement this one, so let me show you the code here and explain you there. So here I have added the code for this top view. So I am taking node, right, as I have explained. Then I have taking distance and level and the map, right? So map is a map of integer, that is distance, and the pair of node value and level, correct? Here line number 36, you can see this one. And then I am calling this top view here with root 0, 0 distance and 0 level, and map I am passing it here, right? And here I am extracting the node values from the map. As the map is already sorted, so no need to sort it again. And I am just taking the this pairs first value, that would be your node value, and I am pushing this values into the vector, and I am returning this vector to the main function, right? Now coming to our this main top view function. Here, if node is null, then we will return back, right? And if node is not null, and see here I was saying, like I was checking if the value is for particular distance, the value is there or not. So that is what I am checking here. Map.find d, for particular distance I am checking. If it is not there, it means map.end will be there, right? So we will insert the new value here, new node value plus the level of that value, right, directly. If the value is there, means this condition is false, this condition is false. In that case, we will come to the second condition, and here level of the current node, whatever we are trying to insert, is less than the already inserted values level, right? It is less than the already inserted values level, then only we will insert, else we will skip. Why? Because when we look from the top, then the lower level will always be on high, and that might hide the lower like higher levels values, right? That is what we saw here, right here. So here in this case also, see here, so this is the 0th level, this is the first level, this is the second level, right? Now when we see here, this is the distance at 0 distance, right? This is -1 distance, right? This is -2 distance, this is 0 distance, this is 0 distance, this is +1 distance, and this is second distance. How I am calculating this? See, it is very simple. It is very simple. See here, uh, when we going left, see node arrow left, we are doing d -1, distance -1, right? And when we are going right side, see distance +1, and level always we are incrementing, because when we will go down either left or right, that would be the next level. So we will start calculating the distance from the root, right? And we will take 0. Now if we go left, then we will say -1, and if we go right, then we will say +1. That is what we are doing simply here. So left, root arrow left, we are going, so -1, and again we are going, so we will add -1 again, so it would be -2. And from here we are going right side, so just increment the value, that is +1. This is for left, right, and this is for right, correct? So +1, so -1 +1, that is 0. And here also we will go first right and then left, so it would become 0. And here, so right, so this same distance we are basically hiding, this one 60 and 90. Why? Because this would be on top, and that is what I was saying. So lower level would always be on top, correct? And that is why we have added this condition here. Current level value should less, if it is less than the whatever the inserted values level, then we will update, else we will skip. I hope you are getting this. So this is the first approach basically I have used to solve this problem, and this is the pre-order. If you remember my pre-order videos, so this is the pre-order traversal. It can be implemented using the post order also. It can be implemented using the level order also, right? So this is the recursive. In level order we do the iterative approach, right, where we take the queue and we will insert the node values, all those in the queue, and then we will take one by one, and then we basically iterate for the all the nodes of the binary tree. So that is the second approach or third approach, you can say. And yeah, so that's all for video. In next video we will cover the bottom view approach, and there I will take the like I will solve the problem using the level order traversal. So thank you for watching the complete video. See you next time. Till then, keep learning and keep exploring.